Hi, and welcome to the Modern Analytics Academy first vignette session. Several months back, we started a series called Modern Analytics Academy, which you can find at aka.ms/MAA. We hope you found that content useful. If not, check it out. We'll look at what it is in just a moment. And since that series, we've had a number of questions come in, usually around new features, on how that might impact design, or specific questions on architectural guidance that we didn't address in the original series. So the idea here is to expand on the series with short topical sessions to augment that original content. And if you've got session ideas that you'd like us to explore, let us know. Give us feedback in the session evaluation, or you can leave feedback directly in our GitHub repo, which you'll get to through the aka.ms/MAA link. And you'll find that these sessions are going to be of different length, whatever's appropriate for the topic. So in some cases, they might only be 10, 15 minutes. Other cases will go a bit longer. This one will probably be a bit longer than some of the other vignette sessions that we've got lined up. So in this presentation, we're going to introduce data governance, what it is, why you need it. And for the most part, we're going to stay really high level here and not get too deep into any specific implementation. If you've already gotten started with implementing data governance within your organization, or you're already familiar with the core concepts, you might want to consider skipping this session, bump it up to 2x speed, or whatever seems appropriate for you. The reason why we just decided to start with this session is because one of the most frequent questions we get is, I'm not exactly sure why we need data governance to begin with, or I'm not sure how to get started with data governance, or I'll hear about specific challenges embracing a data governance strategy within an organization. And the reality is that no software solution can do any of this magically. Software can make it easier to manage. It can make it easier to maintain a solution, and it can also make data easier to discover within an organization. And so hopefully this guidance will help prepare you to implement a strategy and illustrate why that's important. In our original sessions, we started with what we called 5 pillars, covering the basics from data acquisition all through visualization. The 4th pillar, data governance, we dove quite a bit into Azure Purview and how to get started. One of the things that we wanted to do in one of our future sessions is dive deeper into specifics like how to leverage the Atlas API, taking advantage of the policies, which is currently in preview at the time of this recording, and then also going deeper into lineage. So your feedback here will be really important to help us determine which sessions we should prioritize. Taking a step back, though, is a lot of the questions, as I mentioned earlier, why do we even need data governance at all? How to get started? And sometimes questions like, well, what is master data? This session is designed to go above even the previous session that we did on Purview. The idea here is we'll start at a complete 100 level. The session we already did on Purview is closer to a 200 level session, and then we'll follow that up with additional sessions that go to 300 and 400 level on various topics like Atlas and policy management. Our agenda today, we'll start with what is data governance and why do we need it? Then we'll look at requirements for governing data in an enterprise. So what you're going to need in the organization to make this work. We'll talk about a data governance framework, managing master data, and then the technology for managing end-to-end data governance. Now remember, this presentation is high level. So we're talking about the basics of data governance, designed really for technical decision makers, IT management. We're not going to be diving into those deep topics like managing lineage or Atlas APIs and catalog management. We're going to save that for future sessions. So a great place to start then is, what is data governance by definition? And one of my favorites is from Wikipedia because it's simple in that data governance encompasses the people, the processes, and the technology required to create a consistent and proper handling of an organization's data across the business enterprise. So what I like about this definition is that it underscores the importance of people and processes, not just the technology in data governance. So As I mentioned, software can help us orchestrate and carry out many of these traditionally difficult tasks in data governance, but we really need to have the people and the processes they implement in place. Without that, no solution is going to be effective at data governance. So why do we need data governance? Or perhaps put another way, why now? There are many contributing reasons, largely centered around digital transformation. We can store and process almost unimaginable amounts of data, and organizations rely on data to effectively engage with customers. Businesses leverage data and analytics to optimize operations and gain efficiency. Organizations seek to increase data democratization, making data more accessible to employees and stakeholders in the enterprise. And this data, it might be customer data, marketing data with clickstream or CRM system integration, customer support, and operational systems. Not only is the size of the data estate increasing, but the kind of data has become increasingly complex. Not only do we have well-structured data, like you would find in a traditional database, most organizations have data that is semi-structured or unstructured, perhaps in JSON, XML, or CSV, or other flat files. Some data might be compressed or encrypted, and documents might be binary, like JPEGs or PNG files that might contain scanned form data, for example. That's part of our data estate. And we might also include documents like spreadsheets, Word documents, and PowerPoint presentations, and so on. So in some cases, our data also exists in legacy applications that is only accessible by an API or other interface. Most organizations use multiple cloud providers for infrastructure, services, data, and although these surveys are from a few years ago, it helps to illustrate that hybrid and multi-cloud is becoming much more of the norm. And while this is probably not very surprising, you might remember that it was really only a few years ago where many organizations never saw themselves adopting the cloud. While this approach increases flexibility and scalability, it also increases the complexity, and that requires a higher level of governance, and we'll explore why. One of the first complexities is with data flow. Data typically needs to move from one system to another, and it could be from a data feed that was captured transactionally on premises or in the cloud. An order might be fed into a mainframe that ultimately flows into a data warehouse for analytical purposes. But oftentimes this data is not just moved, it is also transformed. And this transformation and movement of data is a key principle in data governance that we refer to as data lineage. And we also need to account for things like data quality, security and access, and policies for classification and retention. Let's take a look at an example of data lifecycle. A user might make a purchase, or perhaps a device creates a piece of data. That data would be stored in one of the many systems throughout our organization. So perhaps in this case, if we have an order, it might be placed in a transactional database like Azure SQL Database or MySQL. The type of data will dictate how that data flows throughout the system. Usually there are one of two paths, a hot path and a cold path. Data might flow through both. Cold path for batch processing, where the data can be summarized and computed on, such as daily orders, or real time, where speed and latency are critical. That data may ultimately be transformed and summarized in a data warehouse, usually through an ELT or ETL process. Real time might be processed through an event processing system, such as Kafka or Event Hubs. Because of the number of sources and transformations of the data, organizations might use a common data model or CDM to establish some kind of semantic consistency. And so having a strong data model would allow us to not only understand the data in a more consistent way, but also enhances the portability of that data between systems. So this essentially allows us to integrate different systems together. We'll advance through these to look at the bigger picture. So here our final diagram includes all of the analytics, including AI and ML, reporting, and dashboards. This life cycle of data is where data governance can help us ensure data quality, to track that lineage of the data throughout that life cycle, provide information from the metadata to help users build a business glossary, and to provide a mechanism to ensure policies are implemented, like data retention and access rules. Data governance also allows us to better understand the data estate to ensure compliance with relevant laws. So obviously this varies based on where an organization is located and also where they conduct business. But undoubtedly, most of us are familiar with the concepts of GDPR, designed to promote privacy protection and data rights in the EU. And in some cases, organizations will need to comply with several overlapping regulations. So it's crucial to have a governance model in place so we can better ensure compliance. In fact, in the US alone, there are many local laws that vary state by state. So this graphic from IAPP shows the complexity of data privacy laws in the United States, as different states have adopted different rules, and that may complicate how we handle data. So a governance model will help us understand how to achieve compliance regardless of where we do business. So now that we have an overview of what data governance is and why we need it, let's look at what the requirements are for governing data in a modern enterprise. You'll notice that the requirements covers quite a bit of ground, and at the heart of data governance is the data itself, and these are the first 3 bullets. We have to know what the data is. At a granular level, this is referred to as entity definition, with an entity being an object in a data model. This usually requires a common business vocabulary because individual business units might have a specific domain and often imply definitions that might not be understood by other units. The next 3 are people, processes, and policies. People within the organization may belong to one or multiple roles, such as a data owner or data steward. And at the top of the entire enterprise, this is often under the CDO or Chief Data Officer or similar role, depending on the organization. And we'll work with the stakeholders within each business unit to develop the processes and policies to govern the data. This includes management of master data, which is data essential for the enterprise or the business unit, such as customer or product data, but typically the master data itself does not include any transactional or analytical data. Lineage is another aspect required for effective governance. So as data moves throughout the system, our lifecycle, it is often aggregated and transformed and summarized, so we need a way to be able to track that, and this is referred to as data lineage. And finally, we need the technology to help make some of this possible, ideally being able to scan and identify data, enforce rules and policies, and provide insights. So as mentioned on the previous slide, the business glossary helps us establish a common vocabulary. So for example, one group may have a report with total sales. Another may simply refer to this as sales. And another might have gross revenue or total revenue. Are they all referring to the same thing? Is that with or without sales tax? The goal then of the business glossary is to clearly define what these entities are, so there's no confusion to a user to understand what the data represents and to have consistency across the enterprise. Another requirement of a governance strategy is the ability to govern data regardless of where it originates from or how it traverses in the data lineage pipeline. As we discussed earlier, more than ever, data resides in multiple formats and may be sourced from many different systems, so transactional systems, edge devices, external data, and it might span multiple clouds and data centers. To look at this with a bit more detail, here's an example of the type of information we'd be looking to capture. First, understand the data entities and the relationships that data may have with other entities. We'd want to classify the data as appropriate, and we'll look at this in a moment, but based on that classification, we can then define the policies that define how this data should be governed. So for example, for highly sensitive entities such as credit card information, we would classify and handle that data differently than, say, data that has no PII or might be publicly available. We'd want to ask specific questions such as, well, what data is being collected in order to build a data glossary, and then identify the systems and their locations, and also fill in the lineage of that data, so how it moves from one system to another, and understand what that business purpose is, and naturally the sensitivity of that data. We've mentioned classification a few times, so let's take a closer look at what we mean by classification. Typically, we want to think of classification 2 ways: confidentiality and retention. Confidentiality can range from full public information that anyone can access, such as open government data, and then as we move down the chart, we can see the progression of confidentiality. So data might be internal use only, such as data that all employees in an organization might have access to, but not to be shared outside the company. Confidential data should be available only to those who need access for a specific task. So this is usually a small set of individuals in a business unit. In some cases, data might be shared externally, typically using an NDA. Sensitive PII is typically what we think about when it comes to our personal and individual data. And this is at the heart of many privacy and disclosure laws we're seeing worldwide. Hand in hand with confidentiality is retention, and that is how long the data should be retained. In some cases, there may be no need to keep the data at all, or there might be specific requirements to keep data for either an internal policy, legal compliance, or other reason for a set amount of time. And retention rules may require us to delete that data after a set amount of time. It's possible that organizations may have more or fewer classifications. The important thing is that the classifications match the entities for the specific business purpose. Now let's take a look at the roles and responsibilities. Every organization is different, and the organization needs to have the right people in place in order to answer these questions. At a high level, this allows us to define the business glossary and define policies, but also ensures organizational compliance so we can have accountability within the different business units. Questions like, who are the data owners would be common in any data governance implementation. But some questions may be tougher to define and to answer. So for example, if there's product data included on marketing materials like advertisements and brochures, who is responsible to ensure data quality? Likewise, if there's a system that processes order data from a customer directly, say through a website, who is responsible for overseeing data quality of the submitted data? So both of these questions imply data quality, but would have very different people and mechanisms in place for their implementation. And in my opinion, this is one of the hardest aspects of effective data governance. In addition, data governance needs processes for how data entities are defined in the business vocabulary and setting standards for how that data is classified and determining the appropriate steps for managing that data. Now, these questions are not meant to be an exhaustive list, but rather the kinds of considerations to have when discussing data governance. Now, while developing these processes might seem like something that is defined once and completed, it's often an iterative process, and it should be revisited as businesses grow and change. They might be evaluated when new products and services are launched or expanded, business acquisitions that might have occurred, or any new laws that need to be considered. Once the processes have been developed, specific policies and rules can be developed to support those processes. So specifically, there will be policies on data integrity, data ingestion, policies that enforce security according to the classification level, retention policies, and so on. Now, many of these policies work together. So for example, integrity, ingestion, and quality policies will all play a role when data is born, so to speak, or brought into the organization. Security policies will help define the appropriate level of access needed by roles within the organization, and retention policies will help define how that data is managed in backups. So we started with asking the question of what data governance is and why we need it. We looked at the requirements for governing data in a modern enterprise, and now let's look at a data governance framework. Borrowing upon our definition of data governance and taking into consideration the requirements for data governance, we've recognized that effective data governance requires the right people in place to establish, coordinate, and enforce our governance processes and policies, beginning with the vision and the strategy. We know that technology must be part of the solution, and that would be in the form of software and hardware that can work with and track the data as it moves through its life cycle, or what we refer to as data lineage. We also know that data exists across many devices, from the edge to the data center and the cloud. If we look a little more carefully at the vision and strategy, for example, we'll start with the stakeholders. And this might be with the chief data officer or similar role depending on the organization. Stakeholders within each business unit are identified, and a vision statement, including the purpose of data governance objectives, is defined along with the various success metrics or KPIs. Businesses can identify the impacts, such as areas where ungoverned data is having the greatest business impact, and this will help prioritize where to start because any implementation will take some time. And typically, an organization would prioritize areas that have the largest impact. So for example, a risk due to data breach or other security incident. The data lifecycle has also been discussed through a concept called data lineage, and that is data typically flows into a system and is often transformed, moved, summarized, copied, archived, and eventually destroyed depending on our retention requirements. We'll refer to every piece of data as a data entity or sometimes as a business entity, though business entity is often used with master data, so sometimes they're used interchangeably. Our data entities are vast, so it will include all of the data in our transactional system, like orders, sales, and also the master data, like employees, products, and assets. The vision and strategy begins with roles and responsibilities, and this varies significantly across businesses and often starts with either the CIO or the CDO. And from here, the data owners and working groups can be established, typically aligning to the various business units within the organization. Some of these groups can help identify and coordinate governance work within the business unit, while the data owners, stewards, and security groups may work across different business units. I've underlined the two most common universal roles in any data governance strategy, the data owners and the data stewards. While some roles and titles may vary across organizations and industries, data owners and data stewards are fairly ubiquitous. As an example, and for guidance purposes only, here are typical roles and responsibilities, and they may vary based on need. In some cases, these roles could be consolidated, but the key here is to look at the responsibilities and assign them to the appropriate individuals. So, for example, the data owner is the senior business stakeholder accountable in overseeing the data quality and protection of a specific area or entity across the enterprise. Typically, decisions of how that data is managed, classified, used, and maintained relies with this individual. Now, in contrast, the data steward is responsible for implementing and providing expertise on a specific data domain, typically coordinating that with other data stewards. Now, notice the difference is identifying the accountability and the responsibility, as you typically want separation of these concerns. So what might an organization with a data governance control board look like? Well, here's an example. Underneath the executive sponsor, the control board consists of several roles, including the data governance leader, one or more data owners, one or more subject matter experts, and typically an IT a data lead role, such as a chief data architect. Under the control board, there are a number of working groups that work within each business area. So the working group understands the data domain at an expert level, but the coordination of the working groups is done through the control board. So in this way, problems of data isolation and data silos are more avoidable, and the control board can help ensure standards are enforced across the organization. So as an example, for a data entity-based approach, looking a bit more at the working groups, each group is scoped to a single data domain, such as customer, product, and orders. Now, in this example is very similar to what you might find in a canonical master data catalog, but this could really be any data model depending on the organization's size and complexity, and the working groups might cover multiple entities. There are essentially four processes involved in the data lifecycle, and they flow from one to the other and then back again. And it begins with the discovery phase and how we discover data entities to begin with, and how we define what those data entities are, what their classifications are, and how we choose to define them in our business glossary, and then also define the policies and rules that should be applied, and determining how they are to be enforced and what kind of monitoring and auditing is needed to support that. Let's look at this a bit deeper for the first two. Discovery involves cataloging all the data entities, not just initially, but then how new entities are discovered and cataloged as the business matures. In discovery, we'll want to ensure all the entities are cataloged, data is profiled to determine quality, and the appropriate sensitivity and classification is determined. Now, definitions, these are centered on the creation of the business glossary itself, so we can ensure all data has a common vocabulary across the enterprise. Here, too, standards for classification are established to ensure all working groups work with the data in a similar way. So, for example, identifying PII data, secure or sensitive data, and appropriate retention policies are in place so that data is handled consistently across different groups. When we get to the application of policies and rules, this may vary significantly based on the resources available. Ideally, we'd like to automate as much of this as possible, so Enforcement and integration of these policies can be applied automatically. But in many cases, there are processes that cannot be automated. Data retention, for example, is often managed outside of our governance tools. And while data discovery can often be easily handled through software in identifying our data assets, data lineage might not be so readily observable depending upon the environment and tools used. This is because data transformation and movement can be difficult to track. So, for example, suppose order data is transformed through a custom-built compiled application. It can be difficult for scanning tools to have visibility into this data transformation. And finally, there's the monitoring to audit usage, quality, and security. This is important in both the initial assessment and prioritization of areas to focus on, as well as the ongoing monitoring of our data estate. So how do we define the data entities? Defining the data entities is done within each working group that sets the definition for their business unit, and that gets consolidated into a single data catalog for the organization. So this ensures that there's a single record of truth for a data entity, and a common business vocabulary ensures that it's used consistently across the organization. The policies are applied to the data catalog and then applied universally across the organization. One of the more difficult tasks in a diverse system is consistent definitions across various teams and technologies. So once we have the business glossary defined, a traditional method to disseminate metadata has been a manual process or possibly coordinated through software if the scope of the data was reasonably small. So think of like a small homogeneous system. That's rarely the case today, where we have metadata and definitions that need to reach all data sources, say like traditional databases, NoSQL data stores, data warehouses, big data clusters. We have to take into account how we're going to apply these definitions. And I'm not suggesting that all groups adopt identical naming conventions where it's not practical. So I'm not referring to naming and casing of database columns, but as a best practice, it's recommended to have a clear mapping to the data catalog. So as a very trivial example, if all systems except one process orders with a first name and a last name column, but one system only uses a single name for both the first and last name, it would be important to standardize on a single definition so we can maintain consistency throughout the organization. This is where software can definitely help. Here we'd use a data discovery engine that's capable of connecting to and crawling our data stores. And this will allow us to more easily take inventory of our data and help us define our data entities and populate our data catalog. It would be fairly trivial for the software to assist in mapping all of our entities and fields and even classify them based on the patterns. So that would be identifying potentially PII and confidential information, think like credit cards or social security numbers and so on. So let's take a simple example. Suppose you have a huge MP3 library with all of your music, and I'm dating myself here a little bit, and you only have folder names and file names to go by. So to create a nice library would take quite a bit of work if you were to do it manually, but software packages exist that will scan and index all of that for us, download metadata, apply proper names, and so on. And so there might be a few edge cases that you would have to work around, but even if you only had, say, track1.mp3, track2.mp3, software is sufficiently advanced enough today where we can actually just scan that file, the waveform, and match it right against a database. So in much the same way, our scanning engine should be able to identify data even if we don't have all of the information. If we don't have headers, for example, in a text file, we should be able to recognize the data and even classify it appropriately based off of pattern matching. And this will greatly simplify the coordination and discovery across the entire organization. With that example in mind, we'll want to discover data entities in each source system. By indexing the systems and deriving data entities, we can then match that against known patterns, including custom patterns, and more on that in a bit. The challenge here is the connectors, because as you might imagine, there are so many different types of data stores. For a relational database, for example, we could look at schema names of the tables, column names, and the data types, but we could also look at the format of the data itself to help derive meaning. It might be obvious what an employee table with a social security number column represents, but in the case where we only have the data to go by, we could start to look at common patterns. For example, a social security number in the US would be 3 digits followed by a dash with 2 more digits followed by another dash with 4 more digits, and the dashes might even be optional. By using pattern matching and AI, we can discover this information using various matching rules and algorithms, and critically identify it as sensitive if necessary. Oftentimes, organizations don't realize where all of the sensitive information may be, so having a way for a discovery engine to tell us where the sensitive information resides is critical in taking the first steps to both classify and then secure that information. Now that we've looked at discovery and classification, the next step is policy. In some cases, data is truly open and public, and that's not to say it is necessarily publicly accessible, but rather contains no sensitive information and no business value in and of itself. So for example, weather and temperature data. But most data, as we discussed earlier, will have some form of classification beyond public, whether it be for internal use or highly classified. Based on the need, a policy can be developed that helps determine requirements like quality or sets access and security policies and retention policies. It's possible that data will require different policies depending on where the data is located or the sovereignty. We'll express these policies through specific rules. So in effect, a data source will have data entities defined with a chosen classification, and then appropriate policies that contain the rules to enforce those policies. So what would our rules look like? For data quality rules, we'd want to ensure that data falls into a known set of valid values and meets standardization rules. So for example, if we would like to have a data quality rule on a US-based phone number, we would typically have an area code, a prefix, and then a line number. We know it must consist then of 10 digits, so we can define valid values that reject or remediate invalid numbers. And we can then set standardization so that we store them all the same. That might be with the area code or with parentheses, with or without dashes. That would be up to us. The core information is the same 10-digit numbers. And how we decide to store that would again be a convention we would decide within the organization. Rules can help define who has access to that data as well, and then any privacy requirements for any applicable compliance needs. And finally, for standardization on retention, we have a common framework, so we could decide how long that data is stored, and backup rules are applied to ensure that it is stored correctly. So there's the right security, the right encryption, and data is deleted as needed. Ideally, we'd have a common fabric to discover and classify data, as well as ensure policies and rules are integrated into each system, rather than relying on manually implementing these policies. In this way, enforcing policies is not something that would require intervention to implement and would be done so automatically. Admittedly, this is a bit of an ideal state, and the amount of manual work required to implement policies is going to vary based on the architecture and support of the software. Once implemented, the final piece involves the ongoing monitoring and auditing activities. As businesses grow and data needs change, discovery and classification is an ongoing process. So monitoring allows us to see what has changed, where the weak spots are, how data is being stored and used. Ideally, we'd want this in a dashboard so we can gauge progress. Implementing some of these policies is not something that will happen overnight, but in order to evaluate our progress, we need a way to measure it. An exciting aspect to all of this is how AI can help. As we inferred earlier, AI can assist with discovery and classification, and more importantly, even assist with recommendations, auditing and monitoring, and detecting problems before we might even realize there are issues. So, for example, abnormal usage patterns or a change in the data that a machine learning algorithm can detect might help prevent problems, whether they were accidental or malicious, and take appropriate actions. So what kind of actions? Well, in some cases, manual data governance is needed because there are no set policies. For example, if there's an abnormal trend detected while auditing, that may or may not represent an issue, but requires further investigation into the source system for possible reasons and causes. In other cases, rules might simply flag and create an action item for remediation. Ideally, the system would be able to fix issues for us, so apply formatting rules to poor quality data if possible. Let's sum up then how this framework can be implemented with technology. We need a centralized data catalog to hold our business glossary and to coordinate data discovery and classification with our different business groups across the organization. We need centralized storage, a data lake, to house our metadata, policies, and the software itself, or Fabric, ties it all together, streamlines our data discovery and monitoring. We mentioned lineage earlier as well, and that is we need to track and understand the transformation and movement of data through its life cycle. If you ever looked at a data warehouse and asked where did this data come from, or what system did this data come from, then lineage should be able to provide that answer. And finally, the ability to manage master data. This is a concept we haven't touched on yet, but we'll look at next. So here now in this section, we'll take a look at that master data and how that integrates with our data governance framework. A master data management system, or MDM system, contains all of the business entities shared across the business to act as a system of record, integrate disparate data, and improve efficiency across the organization. Master data consists of entities like, say, products, customers, employees, suppliers, and the management of that data refers to the people and the processes of gathering and organizing the data. So as this image depicts, master data is often consolidated from transactional systems across an entire organization and integrated into a single master data service as a central repository, implementing common data definitions. Effective MDM has elements of governance. Enterprise-wide data governance, then, must work seamlessly with MDM. Typical challenges in managing master data include data discovery, synchronization, quality, enrichment with metadata, and publishing that data throughout the enterprise. So data governance and master data management have overlapping but complementary concerns. The primary role of MDM is to act as the golden record using common data definitions. And the primary role of data governance is to facilitate discovery of data entities that might be used as master data, classifying and cataloging the data, and ensuring quality standards and other policies are enforced. That includes governing how data flows between these systems. So let's look at a typical example. Suppose our system contains customer data and we have multiple marketing channels for reaching all of our customers, all of which require consent as part of our GDPR compliance. Applications like a website can capture this consent, say through one or more checkboxes indicating that the customer would like to receive product updates and news. This information would be classified appropriately and would ultimately reside within our master data, but there are several systems that consent would go through before it reaches our master data system. But what happens if the customer calls customer service and asks why they are receiving a certain promotional offer or email, text message, that kind of thing? While the MDM system would have a record of the consent, how do we govern the flow of that data? It would be critical to have all systems governed to control the quality and flow of that data between systems. When did the user opt in? How can we be sure our systems are communicating appropriately? Taking a step further for GDPR, users may invoke rights of portability or the right to be forgotten. Do we have a mechanism and data stewards to handle these requests and to process perhaps any objections that might come up? And by objections, I'm referring to edge cases where a user might request to be forgotten, but may have an open account, which would invalidate such a request. If you're wondering where your organization falls in the spectrum between ungoverned and fully governed, we have a maturity model you can reference. On this and the next slide, we're looking at a couple of tables detailing the governance maturity model that covers different levels of maturity in the people, the processes, the policies, and the technologies. Now, admittedly, this is a bit of an eye chart, so I certainly don't expect that you'll be able to read this right now, but I'm mentioning it here as I'll have this on the MAA site for you to reference, and we'll have that link at the end in a moment. The first column, ungoverned, is completely lacking any implementation, whether it be having the right people identified or having any processes in place at all the way through fully governed on the right. It's certainly possible to be at different levels of maturity in each section. The benefit of this model is that we we can use it to help provide a roadmap for implementation as a way to ask, what do we do next? If we look at technology, ungoverned would be lacking a centralized data catalog, having no lineage or stewardship tools, and so on, all the way up to fully governed, which would implement all of the items in our ideal framework that we've laid out. Realistically, it's likely any organization will be at various phases within this maturity model. Use something like this to help identify weak areas and prioritize the ones that are most important to your organization. The final piece of our agenda is technology needed for end-to-end data governance. Clearly, technology is needed for effectively implementing a data governance strategy. On the right, we have partner technologies on Azure specializing in master data management, data integration, data discovery, and you might be familiar with some of these, such as Prophecy, Informatica, Qlik, Talon, Tamer, Semrucki, and others. On the Microsoft side, we have various capabilities in Azure, such as the Azure Data Factory for ETL and ELT, data lake storage, and the Common Data Model. Azure Purview is Microsoft's data governance solution designed as a complete platform as a service and was the focus of our previous presentation. And because there have been new features in Purview since our last session, we'll focus on these in our future sessions. As a quick overview, Azure Purview acts as a unified platform with a data map as the foundation. This data map is essentially a large graph database and is extensible via the Apache Atlas API. So while Purview does have out-of-the-box integration with many platforms, the extensibility is there for custom integration if needed. The Purview engine offers automated scanning and classification of data assets and can extract metadata and lineage information. Empowered by the data map, the data catalog offers a business glossary, search capability, and the ability to view the data lineage. Data Insights provide several different reports to provide insights for various roles to gather information on assets in the data estate, scan information and other administrative data, classification insights, and sensitivity labeling insights. Some of these features are in preview right now, which is early April 2022, such as the data policy and data insights. To learn more about Purview, check out our previous session that dives into much of this with the basic features that were GA at the time, and we'll focus on some of these preview features in our future sessions. So this wraps up our first vignette session. For those looking to get started with data governance, I hope some of this information was useful. I'll be updating the aka.ms/MAA site to house the resources mentioned in this presentation. It might take me a few hours to get everything organized, so please check back if a new section for our vignettes is not yet visible. For those looking for more in-depth sessions, first, thank you for hanging in there. Let us know in the chat or within the repo what areas you'd like us to prioritize. Would you like more information on Atlas integration or policy management, custom lineage? Your feedback is important and helps us determine and prioritize which sessions to do first. Thanks again for joining, and we hope to see you next time.